doom 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 down. Ha-na-na. Okay. All right. This is a 3-mate. Now, I happen to like 3 a lot. He's a buddy of mine. In a lot of different ways, he's been a student. This guy tries really, really, really hard. He does a really, really good job. He does a beautiful build. It's all the small details you got to pay attention to, like all the head screws on the top of the fans are all orientated the exact same way. It's the little details that you can't train into somebody that he's got a full grasp on. Chris at BM Technologies and myself, we've poured a lot of energy into him over the years, teaching him different things, and he's a very smart, knowledgeable person, and I got nothing but admiration and respect for him. So if you're tuning in to listen to me bag on him, his craftsmanship or whatnot, this is not the video. I'm here to tell you, just go ahead and stop watching now, click on, go watch something else, go watch chicks in bikinis go fishing, or swimsuit try-on hauls. There's a lot of that kind of stuff on YouTube. This is not me bagging on my buddy at all, okay? The other thing I want to say as a precursor before we even start is this amplifier has had the customer all through it. It says so right in the little note ski here that come from my customer. He freely admits in the notes, for some reason I keep blowing. Something's in this amp isn't right. I had the 12 pills. I had 12 fresh pills installed to the best of my ability. I ran the amp, period. The way I was told to. Bad things still happened, period. The main thing that we need to listen to this is so that we're not judging 3 and we're staying neutral. I had 12 pills, or 12 fresh pills installed, plus symbol, to the best of my ability. Okay? Okay. You've heard it. We've all read it. It's all there. Okay. Let's see. I have an SR 955 HP I used to drive amp with. Now I have a Lescom 959B, which is a 25 watt radio I currently use. Can you put/add a driver to this 12 pill? So an external driver won't be needed, question mark. The answer to that question is I don't know yet. We'll find out. If so, thanks. This is what I'd like to have for this small part. I'm losing overkill values. Okay. He is a neighbor and a friend of my business partner. Mr. E here is a multi-offender. He's been here a couple times. He's had several pieces of equipment come through this shop, is what I'm getting at. So once again, it is my job to fix the amplifier. It's not my turn, my opportunity to bash or judge or belittle anyone, and that's not going to happen. So 3, I want you to breathe deep and go and relax. This is in no way got to reflect on you. I will do the best that I can. Now, I will say this. The guys used to give me shit when I first started, and I'm going to pass this shit on to you. Did he spend more time learning how to braid wire as a girl or hair as a girl than he did actually learning about boy stuff? I used to get all kinds of crap about braiding wire. By the way, beautiful job on braiding this. This is beautiful. I don't care who you are. That is pretty. I remember when I come out and I did that very first, what was it, 32 pill for Roy Smallwood. Everybody's like, oh my God, did you see the wire coming out of that? He had it braided. It was so beautiful looking, blah, 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 blah. That was back when amplifier dinosaurs roamed the earth. You know, Dave Made was king and will always be king, and no one will ever come up with anything original or new other than Dave Made. Back in the day when I first started. And that guy in Idaho, how could he ever know anything about amplifiers? I didn't, but I learned. So, here's the problem that we have. Nope, won't go in a hole. Let's see here. Let's spit on our fingers. Nope, let's see. Nope, still doesn't work. Dang it. Okay, here, we'll try this one. Man, has John Holmes been here? Jeez. It's like throwing a hot dog down the hallway. Okay, we're gonna have to get a little creative when it comes to the connectors, because I don't have these adapters. But you can almost bet $1 million by the end of this video I'll have them ordered. Just saying. Okay, let's pop the tin. So, like most people would look at this and they're gonna go, for my opinion, this looks like this is a used X-Force board of some kind. And it's been repower wired and repower stripped, and there's just, I wish that there would have been balancing resistors installed here and here on our splitters. The balancing resistors have been replaced several times. Let's go on in. I'm really standing here admiring the craftsmanship of what I'm looking at. Okay, because it's a repurposed board, we are going to look around a lot of different things, like all the little solder splashes. Those don't mean anything to me. They shouldn't mean anything to you guys as well. All right. I'm sure what happened here is he got himself a little bit of a turd sandwich, and he cleaned it up and turned it into a, well, in my opinion, a pretty beautiful piece of equipment. Just look at the precision in the work that's going on here. Let's step back and we're going to ignore this kind of stuff. Just set that aside. We're going to recognize that that's somebody else's attempt to fix the problem. But we're going to look at the cleanliness of the solder work, how the pill strips are spaced away from the transistors. And I mean, like, this isn't a hard 90-degree bend. This is a nice, smooth, curved bend. So there's no possible chance of vibration breakage here. There's just a lot of stuff in here that I admire. Like, for example, I mean, it's just, I know what it takes to build at this level. I really do. I think me of most people would understand this. And so when I see little details like this, I'm like, oh, hey, let's look at the heat shrink that's right here on the combiner. Where the resistor comes down and makes contact with the wire, he didn't want to have it accidentally through vibration or movement or shock or anything be able to bump over here against the output transformer. So he put himself epoxy-based marine grade heat shrink on the wire. That's fucking great, in my opinion. There's some differentiation in the caps. We're not going to worry about that for right now. But the overall quality of this build is superb. So to answer my customer's question, if we want to sacrifice these caps, I can easily add a driver's section here. So I'm going to call him, I'm going to talk to him about it. I don't like to do driver sections in boxes. I like to keep everything separate. Especially for guys like this who, well, let's face it, break stuff a lot. No Schottky diode here. No, or not Schottky. No snubbing diode here on the relay across the positive and negative poles, which is a must, so we'll add that. But this is the quality of the craftsmanship and the time that it takes to very carefully lay stuff down like this is just top notch. To put those pieces of heat shrink on, you got two options. And the way I'd do it would be lay the whole circuit out, mark the wire, unwind the whole circuit from the transformer side, cut the wire, add your resistors, and then slide on the heat shrink and then rewrap the transformers. None of these transformers, well, wires cross over each other inside the transformer. They're all stacked nice and neat on top of each other. It's the little things. It's the little things these old eyes see. I'm wondering what material makeup the input transformers are. Not that it's overly necessary. I'll know as soon as I run it, because then I can see what the frequency response is. It'll tell me by looking at the spectrum analyzer. But The other thing I did notice though, and something we're gonna might have to look at here, is this here. This gapping on the input transformer. It goes to ground, yeah, through a choke, yeah. Okay, but this whole transformer has to be isolated. And I can't help but notice underneath all of these transformers, there's a little bit of a solder sploosh from a previous build that was here. And what are the chances that maybe one of these transformers got shifted down and is making direct contact with the board? That can cause a problem. So like we can see a little bit of light here, but we can't see light underneath here, and we don't know if it's shorted. And the same thing going on here. We're not going to do any more damage to it by running it. But other little details, like, let's look at our capacitors here on our output section. They're sitting even with the transformer. These are flat and flush. They're not kiltered down. And what that means is somebody has taken the time to bend the wire on the front side to compensate for the pill strip height. Or vice versa, bent the wire leg on the back side of the capacitor long enough to compensate for the pill strip height. These are things that you cannot train into a builder. These are things that a builder kind of instinctively does. Like, okay, this is the way I want to build. And they're striving, they're reaching out, and they're trying to grab for something a little bit higher standard. And so their brain goes, well, how can I make this better than the next guy? And so they instinctually decide that they're going to fill in that visual aesthetics. The downside to building like this is it is so time consuming. Believe me when I tell you from experience that these little details, they cost you hours and hours in the build, usually an extra day or so. Like all of the resistors, they're all level with each other. They're all built to the same height. That means each one of the legs on the resistors has the same length to it. I can empathize with that because I know how long this takes, because it's the same way I've been doing things now for a decade. The way the disc capacitors are attached to the resistors, they're not just touching and soldered. It's a mechanical connection, so you got to sit there and hand wrap each one of these god darn resistors and then come back and solder it and then trim them all exactly the same. All of those little details requires a little bit of work. And me personally, I built a couple like this where I used the same choke and the amps didn't work so hot. So I ended up just going back to an individual choke. I did have one where it was cross-talking through the choke. Otherwise, this wire was coupling to, this transformer is coupling to this transformer through this piece of ferrite. So, I don't know. We're going to go look at it. I'm not saying that's our smoking gun. I do feel that our problem is going to lie up here, though. Most likely at this cap. I don't believe it's probably ever been checked. At least the guy that had this when he changed the transistors himself. I don't know, the solder work in here is too good. This really looks like Three's handiwork as far as the transistor change goes. This, I mean, it's really good solder work. It's like flowed in here. Like, I mean, this is what you're looking for, is glass work. I call this glass work. When your solder work is as smooth as glass, there's no ridges in it, it's all uniform. I mean, but still, even at that, I see little things in here like this. Let me show you what I mean. Do you see it? Let's go on a little bit closer if we can, and maybe it'll show up for you. Or maybe you can see it now. This is the #1 killer, in my opinion, of people doing their own handiwork, is they don't think to look for these little details. Let's look right here. Now that might not be making contact at this moment, but it definitely can do it in transmission or bouncing down the road or whatever. And it could have gotten dropped on the way here, and that little piece of solder flick fell down. That little piece of solder flick could have fallen in from anywhere. See, we got that solder flick that's just randomly. And you know, you try to minimize that as a builder, you really do. Usually it's on the input side where we'll get ourselves a little bit of solder flick that happens underneath one of the transistor legs, and that'll kill the whole section. And people will go in there and they'll change the transistor and change the transistor, and it's come to find out it's a little piece of solder flick here on the back side of the transformer that's shorted out or something. I've had that happen. Now, if we put 12 volt current to this and this is shorted, this little piece of shmoo is floating around, it's either going to arc and explode, as in far as like the little blob of solder is going to disappear, which won't hurt the transistor, or it's not going to do anything. And then randomly it's going to do something. Now, it might hurt the transistor if the transistor's in operation, but just putting current to the circuit, no, not so much. But dude, all in all, this is really an impressive box. I mean, this is the craftsmanship that went into putting this together is, well, you've got to admire it. I mean, I'm not going to sit here and hate on it or hate on anyone. I'm just saying that you have to admire the time and the energy that went into assembling this. I mean, we can tell there's a little bit of me that rubbed off on this guy. I mean, this is something I've been doing now for a decade. Maybe he got the idea from me, maybe he didn't. It doesn't really matter. It's just smart. It's smart building, and this is what I call not rushed building, okay? We're not slime lining this together, we're putting this together and we give a shit. And like I said, that's something that you cannot train into or pay into a person. That's something they have to already have in them. It's the other little details like, hey, we know we have a chance of this shorting out, so let's just go ahead and add a little bit of freaking phenolic here. And then some guys will go as far as they'll put a little piece of adhesive tape to help support the back end of the transformer. It's just sitting here looking at it. Not criticizing, just looking at it. I want to turn it upside down, give it a good whack, and see if our little... The beginner's guide to this is that we try to chase this little flick of shmoo, and all we'll end up doing is we'll shove it up underneath the pill strip, and that's not right. So what we're going to do is we'll turn it upside down, we'll give it a couple little bangs. I mean, I'm not going to hurt anything, it's already broken, right? We'll see if we can get that to fall out. If not, I'll get the air compressor and we'll blow it out. But if I went up in here with a dental pick and tried to pick that out, I'm just going to create a problem. Then I got to end up pulling the whole transistor out, even though I have a feeling I have to pull a whole bunch of stuff out of this and check it. It's okay. This requires us stepping back and just looking at it and recognizing what it is. Hours and hours and hours and hours worth of labored love to build the best product that you can for the customer. And we don't see it very often. That's the reason I'm taking the time to point this guy out to you all. 3Made. He's a good dude. It's been interesting to watch him go through his arc of learning, because we all do this thing where we have to learn, and I don't care what kind of job it is, I don't care what kind of skill set you're in, I don't care. We all do this thing where we first start out at zero, then we have to learn a lot, and 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 a lot. But we pick all that, the general knowledge, like 80, 85%, 90% of the knowledge, and I don't care what job it is, you get the basic function just rudimentally within like maybe a year or less. In most jobs, it's like 2 or 3 weeks, because that's the way we structure our employment architecture universally. And so we want to get a guy in to do a job, and we're only going to make it so complex that it's something that he can learn in a couple weeks. In the ant building world, you learn a lot. It usually takes about 3, maybe 6 months or a year. And you've got the basics of the solid state box figured out. And so then your learning curve kind of decreases, but it never really stops. So it hits kind of, we get to this point where, and that plateaus out and it just continues on, right? It was neat to watch him go through this learning arc. And now he's starting to go on the, okay. This is neat. This is neat for me to look at, and I'm just admiring the positive qualities of this. Now, as far as his capacitor setups, that might be our problem. Let's go take a look at it. Okay, so this was a clean towel when we started. I literally turned the amps upside down and I smacked it real good. And, well, as we can see, we had a couple little flicks of shmoo fall out of it. I mean, well, once again, this kind of little thing happens. Just happens. It's not a big deal. No one's perfect. We don't live in a perfect world. And once again, when we started out in the beginning, let me totally re-emphasize the fact that the customer claims he was in here and he's working on this himself, so none of this directly reflects back on number 3 made. Let's hook it up and let's wake up the FLIR and let's see what's turning on, what's getting hot, and what is not. So we're going to start on incredibly low power. This is neat. This is a good use of this relay. I want to point this circuit out real quick. Dude, this is just creative, and I admire it. So this is a 3-pole relay, and we're using the 2 outer poles for our actual RF work. So this is our incoming signal. This is the incoming signal to the amplifier here. This is our pass-through signal. This is our output tune off our inductor coil, and then our actual coax connector here. So the RF comes in, goes through across this lead, out to here, and across these 3 poles. Now, this center pole would be where somebody would want to hook up their bias or whatnot if they were wanting to go that route. How he utilized this, and this is totally number 3 technology here. This is smart. I'm putting it out. I recognize it. I see it. This is cool. This is his pass-through tuning capacitor. Because of all the wire length from the coax connector up and around through the relay, across here, back through the relay, and then back out to the coax connector, we have to give it a little bit of coupling to ground. Okay? A little bit of reference to ground so that we can keep this more to closer to a 50 ohms. So the RF wants to come in, pass through the relay, and go back out the other side as smoothly as we can get it to do. Because remember, we're talking about microvolts the other direction. Okay, megavolts, microvolts. Not megavolts, but higher voltage and then microvolts coming back. Millionths of a volt. That's what we're receiving on. So we want to make this pass-through as low as possible. Instead of just attaching it to this bar, like the rest of us would do, or I would do, he tied it here. And then he calculated in the inductor length of the center pole of the relay. So every time it goes into transmission, it's not doing anything. It's isolating itself out, and it's taking the capacitance off of the pass-through portion. But that's pretty slick. That's pretty slick. I admire that. It's pretty cool. Okay, so a little detail. We are on a 1,000-watt slug here, PEP, 1,000 in average, 5-watt slug in reverse back from the Bird 10,000-watt dummy load. We're going to go up here for a hot second, and this is a 5-watt slug. We're going to use a 2950. We're not going to put a whole lot of drive into this, because this isn't the point where we go, oh, look at all the watts it's making. This is where we go, oh, hey, what's wrong with you? Why are you, what do we got to get working? Now this is interesting. The amplifier is off and never had 1 watt put to it. Let's come down here. I want to show you this before it burns up, because it's going to burn up. These are all the transistors on this side of the amplifier. Look at how hot you are, you little bastard. It's just sitting there cruising. And it'll sit there and keep pulling current and melting down until the cows come home. Let me take that picture. Let me change our viewing function, because that transistor is bad. We can sit there and let it cook until the end of time. Take that picture. Okay, I'm going to insert those in the video, this segment, so you guys can see them. This one little pill's off doing its own little thing. Might be what's causing our imbalance here. Wonder how long we can let this run. Pretty much indefinitely, because the heat sink's going to keep sucking up the heat, dissipating its heat and doing its job. So see, nothing else is having a hard time here, is it? Oh. Nope. One transistor is just doing its own little thing. I've seen this before. I got a friend of mine, his name's Alex. He brought me an 8-pill that was built in the same configuration, not by the same guy. Built in the same kind of style of configuration. And the 8-pill would do like 1800 watts one key, and then the next key would do like 800, and then 1800 watts, and then 100. It was real random. Please note, I'm not excited about this. That transistor's garbage. I'm going to let it cook itself to death because I give 0 F's about it. I'd come along and we isolated it down to one section of the amplifier. So we'll say it was just basically this half the amplifier. This one down here on the end, we'd have the flyback was getting hot. And the balancing resistor was chooched, right? I'd sit there and I'd take my screwdriver and I'd just press on the lid and it would make full power. And then I'd unpress from the lid and it would quit. Weirdest, it just happens. Look, dude, we're not talking about parts made in China or Japan anymore. We're talking about, you know, from the other place. How many amps is it pulling? 2? 3? Here, let's reach down here. Let's kick on the power supply. Let's up our voltage. Oh, there's 4. There's 5. Oh, that means it's going to get hot here in a second. Oh, 5 amps. Garbage. Garbage. Okay, let's quit dicking around. Let's get on with this. Okay, so what we got here is I removed the flyback circuit. One of the things that can cause this phenomenon with the transistor is a leaky blocking capacitor. Now, believe it or not, this little disc capacitor here, let's leave it so you guys can see the numbers changing constantly here. What it's doing is it's fluctuating with the room temperature. And no, that's not it reading the capacitance of my fingers. It's the heat of my fingers is changing the value of the cap. If this disc capacitor starts to break down and it lets any 12-volt current through, this is an actual blocker. This is designed to block the DC current but let the AC voltage pass through it and get dissipated in the resistor. If this capacitor starts to break down and leak voltage through, it can cause that transistor to hop on and stay on. Now we know this transistor's effed in the butthole, but let's see what happens. Yeah, it's taken off on its own now. Yeah. Now, this could be a side result of this. So when I first plugged this in, it was all the way down at like 99. Okay. But like I said, it's a 104. And the fact that I can just squeeze on it with my fingertips, I don't have any faith in this cap. So we're going to change that cap out. All right, let's continue being surgeons here, and we'll let those capacitors get bled off by this transistor, and we'll move on. I was saying about how you can learn like 90% of a job relatively quickly, usually within just a couple weeks. The fine minutia of the job, like let's take a guy that's worked at a gas plant his entire life. You think the guy that got hired 6 months ago knows as much as the guy that has worked there for 20 years? No, there's no chance. But the guy that worked there for 6 months probably knows about 65 to 75%. Now that we're saying the same position at the plant, not overall. 65, 70, maybe 80% of what the guy that's been there for 20 years. It's the little things that take a long time to learn. And it's the same thing with amp building. It takes a long time to learn all these little tricks, and it's not to learn the tricks, it's to actually be presented with the problem and then working your way through it. At least that's what I've discovered. This is our problem child transistor. It's showing on the tester as short. We're going to retest it again. Our results say short again. Okay. Lamp on, NPN. Let's go to the analog tester. So it's the being presented with the problem and then working your way through what has caused the problem, more than just let's slap a couple more pills in it and see if that fixes the problem. You have to learn to ask yourself, yeah, this transistor's junk. It's just straight out leaking its butt off. So is the 10 ohm resistor damaged? No. Okay. Getting presented with the problem, working your way through the problem. I've always said anybody can build an amplifier, right? Anybody can build one of these. You're not really a technician, or I'm not even a technician. I consider myself to be a really good tinkerer, okay? Until you got to work through the problem when the thing breaks. 14. This is its matched transistor. So we know the general rule is that you don't just replace one transistor, you got to replace its partnered buddy. So these two are in a push-pull configuration, so they work together. These two, these two, these two, these two, they're all in push-pull. I've found with the Chinesium transistors, China Shmoo, that it's usually best that we don't dick around. Like in the Toshiba days, you could take this transistor, let's say, pull it out, check it. Go, it's got a beta gain of 14. Go dig through your pile of used transistors, find another one that's got a beta gain of 14, and partner it up with that transistor, put them both back in a box, and you're off to the races and running. With the Chinesium components, I'm not as comfortable doing that. We're going to take this one, and we're going to file it over here in the bag of stuff for the end of the year. Bloop, in the bag. With the Chinesium components, I found it's best just to simply go, you know, they're cheap. Well, that thermal compound's really hard. They're cheap. Let's just go ahead and put a brand new match transistor in there. That way we don't have to worry about it. I need to order more of these. Have to call up Tony or Brian Smith and order 100 more or so. Let's grab my little paddle. Yes, I finally broke down and started buying this stuff in bulk. I just like the tubes. It's the way I'd done it since I was a child. And then I put a Facebook post up where I was doing something, and one guy started ragging me a little bit, and then another guy started ragging me a little bit, and I'm like, okay, fine. So, bought it in bulk. So we're going to evenly coat these. What I'm getting at is the inherent stability of these transistors really isn't the greatest in the world anyhow. The transistors are relatively cheap. If we have a problem with one, replace both. I'm sorry, I do not believe that you need to replace them all. Man, that thermal compound is hard as a freaking coffin nail. Okay. I have to call 3 today and find out what he's using for thermal compound. Let that soak in there for a minute. Well, experience has taught me why I was here. Why is he here? You might as well go ahead and check what you're working on. It doesn't take much to just sit here and just quickly get in here with the iron and lift one side of these caps and take a hot minute. Since this has been a problem child for a while, that's a 40 puff difference between this cap and this cap. Whew. Whew. $37. $760. Ooh. Okay. Oh, popped off. $736. Let's do it this way because I'll forget and I'm stupid. Okay. That's a 5, by the way. Is this so wildly dispersed that this is going to be, oh, the flaming gun, this is the, you know, this is the problem? No. This is not good. There's a lot of different things that can cause this, so once again, we're going to err on the side of caution. We're going to set these aside. Because, I mean, really, what's a couple caps, right? So we can combine some 500s and some 270s. Will get us, you know, 770, which will be close. Or we can try it my way. My way, I think, is the way I'm going to go. No. Let's go the 770 way. I was sitting here making these silly, stupid things. And then my brain kicked in and went, hey, dumbass. You got that whole other cabinet full of capacitors. Let's go look and see what they've got. 762. Okay. $729. Nope, rejected. $756. There we go. $729. Put that one over there. $728. $731. That's within 1% of those. Of that. $730. $724, too low. $761. So the ratings on the front of this thing, and they're not lying. This is 750 puff at 5% at a 300 volt rating. And they're not lying. They are, oh, 760, 750s, 729 through 730. We're going to use these. That'll get us definitely close enough to match the circuit. But they're all within range. They're not 720, 760. We're talking maybe 2 or 3 puff apart. That's what we're looking for. That's what we're looking for. So let's go and replace all of those. Okay. The current meter says we're not pulling any juice. The FLIR doesn't show me any transistors prematurely running away or taking off. This is all repaired in such a fashion you can't even tell I was here. And the transformers are warm because of where I soldered. So, take that picture. And now we're that far, we can do this. Okay, so 1000 watt silicon peak. Let's see if we can talk through it. Hello, 1, 2. Yep. Hello, 1, 2. No problem. Really good pass-through tune. Hello, 1, 2. Hello, 1, 2. Okay. That's good. It's good. That's good. All right, let's see what happens here. Hello, audio. Make power. Shutting itself down. No imbalance on the output. No imbalance here at the combiner. It's happy. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, BBI, BBI, BBI. Hello. Okay. So, the combiner is getting a little warm. Like, hello, 1, 2, 1, 2. Take a picture of that. So, hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2. All the transistors are turning on. Hello, 1, 2, 1, 2. Got no dead holes. Don't like our dead holes. Hello, 1, 2. So what is odd, so we've got heating here, but no heating here. Hello. And what I mean by heating is that this resistor, our background temperature is 73, and our resistor is heating up to 87. Now that could be just these transistors settling in, or that there's still a little bit of an imbalance. The fact that it is not showing up over here in our combiner ring is a good thing. I want to check this cap. I do. This cap and this cap are a 130. That tells me that this one's most likely at 130, so I've still got something that's dragging in this circuit. It's dragging back just a little bit. Could be a little piece of solder, slobber, or something. Let's go double check that. Hello, 1, 2. Hello, 1, 2. This one is ice cold. Hello, 1, 2. But that one's hot. Hello, 1, 2. And that one's hot. Hello, 1, 2. Well, now we pull our head out of our ass and we step back and look a little bit. This resistor's been replaced a couple times, and so is this one. That one never has. And what were the two caps I checked? This one and this one. I wonder what this one reads. Just saying. And then what? Then if that cap turns out to be the same value in the 130s range, we got to go ask ourselves, what's different about this section that is different from these two? Could be a myriad of different things. I'm gonna go check this cap. Oh, that cap turned out to be in the 130s. So 200. These transformers are not touching. I'm certain that those are. Okay, well, I doubt that'll be it, but let's give that a shot. Let's heat this up and kind of rotate this transformer up away from the board a little bit more. do the same with this side. Got the same problem going on over here. Nice physical gap. Hello, 1 2 1 2. Hello, 1 2 1 2. Hello, 1 2. Nope. Nope. Hello, 1 2. Hello. Still making the same power. These two are definitely falling down. This section is dragging. It's called working the problem, boys and girls. Working the problem. So this took a few minutes to work through. And then it dawned on me I'd seen this before. This combiner was getting hot, and this one was getting a little bit warm. And I triple checked everything, and I went, wait a minute, I've seen this before. I've seen this phenomenon before. So what I did is I went and I pulled these guys out, which are 200 puff. And it's our input capacitors here, here, and here. And I replaced them with 120 puff caps. So put 120 on the input, 120 on the output. Very dangerous place to be, by the way. You don't want to have it that close. You set yourself up for an oscillation potential at that point. So I ran it, and this immediately got cold, and this one got hot. And this one started getting a little bit warm, and I went, found you. I was built a 48 pill like a million moons ago, and the problem I have with that 48 pill is that the output combiner ring it would be like, it would tell me that this port had a problem, right? So I'd go and I'd tear this whole section apart, and I couldn't figure it out. And there would be nothing wrong here. So I put it back together and, change a couple little things, and it'd tell me this port had a problem. But all of a sudden this port was good, let's say on a 48 pill, right? I chased that for a month, and it finally came to me, I'm like, well, I'm gonna start changing values outside of what I normally use, and I'm gonna see what the results are. I ended up changing the input capacitors, and my problem, I literally chased the heat around the ring, and I kept going lower and lower and lower in capacitance, and it just stopped. The whole circuit settled out, chilled out, and ran. And I went, all right. So I went a little bit lower, compensated for it with a little bit more input capacitance, and it ran like a Swiss watch, and has been going ever since. So I went to the 120s, which is a huge jump. 80 puff of capacitance over 3 different ports is a huge jump. Well, I went even lower. I took another set of 120s and dropped them in there. So now we see 60 puff at each one of the input circuits, still leaving the output alone. Compensated a little bit on the output and slid that tube in a little bit. Heating issue, gone for the most part. Then I started noticing I had an inefficiency going on the output network, because now everything is getting warm, but it's all getting warm at the same rate. This, and then 3 ports over here. By the way, these resistors are still good. I just replaced them with the 5 waters and replaced this one with the 5 waters so it would all match, because this hack fuckery here that was going on, I couldn't let it go out with that in it. So I just put 5 waters in there. Cleaned up the joints, they're all nice and smooth and clean now and appropriate. So end up pulling the combiner out, and the combiner had one too many turns in it for what we're trying to achieve. So it had in, out, back in again, and out. It's one too many turns. So I changed it so it goes in the combiner, and then back out. So they call it a 1-to-1 instead of a 2-to-1. And all the problems in this box settled, like, went away. Now what I want to show you is, we're going to change one more thing, but I want to show you the difference of making sure your inductor's appropriate, how it affects your power output. Okay, so we have this just laying in here. This isn't soldered in, it's not attached to nothing. This is a 1000 watt slug in peak, okay? Just turn the amplifier off. See what radio I'm on, 2950 at the moment, start low. Hello, audio. About 20-25 watts. Hello, oh, I'm not plugged in, that's why you had your fingers in it. Okay, ready? Hello, 1, 2. Hello, 1, 2. 600 watts. Simply take our shorting bar over here, bend it up out of the way, bend this around so it makes contact. Hello, not making contact. Hello, audio. Hello. We just picked up 200 watts by changing our tune by shorting out a whole coil. Hello, 1, 2, 1, 2. So here, check this out. This is our input tune. Hello, 1, 2, 1, 2, 1, 2. Vastly better than what we had when we started. And what I mean by vastly is half a watt. So let's not get too carried away with the vastly terminology, I guess. Let's go ahead and we'll pull that out of here. Let's disconnect that shorting bar for a second. Hello, 1, 2. Now, all we did, now our circuit's in resonance. Or was in resonance, now it's out of resonance. All we did was remove the shorting bar, so now it's just hanging in free space. We lost our power output. Hello, 600 watts. And our input reflect, hello, went way up. Okay, so now how that works on the lower end of things is this combiner ring is now warm. Okay, the amp is making the power. The circuitry is not resonant to let it come out. The simple way of stating it. The unihenry length of the circuit isn't resonant with the amount of capacitance that is needed to properly couple it for the transmission of the electrical potential at a stable 50 ohm environment. Nerd talk. My way of saying it, yeah. Amp's making power, can't come out the box. So where's it going to back up to? Resistor, 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 resistor. How do we eliminate that heat? So we take our shorting bar, solder it right about here, because I've been dicking with this off camera, you can only bet yourself. So it only wants to have this amount of henries of turns as inductor being present. So let me go ahead, we're going to solder this in place. But how that translates out is as you go up in power, we're now talking, and you can overcompensate for this. If your output circuitry isn't resonant, you're going to be over here messing with your input, trying to get your input down. So, tomato, you know, let's grab some solder. I gotta change tips on this iron. This tip's just about worn out. I'll put this so it's kissing right about there. So that wire's kissing that wire. Let that thoroughly cool off because now it's going to be hotter than a $3 pistol. Let's get in here and trim that off. Get rid of that little shkamukshka. Hook this back up. And now with that 20 watts of drive, hello, we're getting about 800 watts of power Hello, 20 watts of drive. Okay, so now let's jump over to our, if these are imbalanced, something was smoking at this point. Let's jump over to the 490. So we're going to go from 20 watts of drive, 25 watts of drive to about 180 peak. Now we both know, you, me, and everybody else that's going to watch this in Radio Land, we're going to jump to the corner. Off the scale. 2x, off the scale. Okay, finally down to 5x. So with a meager 180 watts of drive, 1, 2, about 2,300 out of it, which puts us right on track to where we want to be. I mean, ultimately what we want to see is about 1,000 watts per 4-pill section for this thing to run stably. And so all that run time, zoom out, come on, all the way out. All that run time, and we got that going on, got that going on, we got that going on, we got that going on, we got that going on. So I'll show you those pictures. I'll throw them in there via post and post edit. So, okay. Yeah, it was a little bit of a headache to figure out, but please note, I never changed these capacitors. That's the same tuning capacitors that were in here when the box was built. All I did was refine the output circuit and change our capacitance values here, here, and here. These 3 spots. Changed, of course, the output tune just a hair, slid this in just a little bit, added another 50 puff to it or whatever, but the output capacitor stayed the same here. Number of turns, turn ratio, transformers, we did change these. I mean, it's close, but that's the main reason that it kept smoking, is you could change transistors till the end of time, till the cows come home, till you're blue in the face. The satellite circuitry around it isn't actually dialed into the transistor. You know, you just don't know until you know. So then I got that nightmare figured out. I want to call my customer and see if he wants me to add a driver to this thing, and I'm going to do everything I can to talk him out of it. Because me personally, I like to have a driver as its own individual thing. Because let's say you have a problem with your driver, your whole final section's now out of the equation. So you're out of your rate. You're now all the way down to being barefoot. Versus running the radio and the amp, getting 3,000 watts out of it, or 2,500 watts out of it, or whatever. You know. And then you're going to add switches to bypass the driver. That never works out well. It always ends up to, well, oops, I flipped the switch the wrong direction and I overdrove the box. Kills the whole box. So, me personally, I like to have stuff separated. You know, you want a 2-pill to drive this with, great. Here's a 2-pill, set it aside, put your radio into it, whatever. 4-pill, okay, whatever. Yes, we got it. Everybody gets it. So, just a little jumper over here helped us pick up. I mean, you think about how that graduates out. So we picked up 200 watts, and we'll say that it picked up 200 watts for every 1,000 this thing's going to make, right? So we found approximately 600 watts lost. They're just going to go up in heat, either in the resistors or back into the transistors. Whatever. Everybody's learned from this, moving on. Got it, everybody's got it. We're coming on the tail end of this thing. Let's start down here. So I've got the 2-pill driving this 12-pill. So it's 1,000 watt slug in peak at the moment. I'm going to show you drive. At 0 and 2. So we're making about 400 watts-ish going in. Let's go ahead, we'll turn on the 4-pill. We're going to go on up to directly on to 5X now. So if we get past the 30, that means we're over 3,000, right? Hello, audio. Hello, audio. Box is in balance. Circuitry is working perfectly now. So, once again, to prove how healthy this thing is running, take another picture. That's the last time we're going to see a picture in this Vigeo. Everything's in balance. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Audio, 1, 2. Everything's happy. Nothing's getting hot. Let's run this dead key up a little bit, so we're not pretending like we're on sideband. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Hello, 1, 2. Fixed. Now we can talk about modifying it up if the guy wants to. So let me give my customer a call, like I said. Yep, enough said. Hello, audio. Hello, audio. That's just hitting it with a 2950 and a little bench 2-pill. Not getting overly carried away or nothing. Whew. This has been an interesting day, man. I think everybody's just having a bad day, not just me, but everybody. Everywhere I've gone today, everybody seems like they're just grumpy as all get out. Nobody's wanting to smile and be nice to each other. Stimulus money has disappeared, I think is the problem. Well, this is it. We're done. I called the customer. He says he doesn't want to do a driver. He's got a bunch of other radios he's going to use now. To just totally disregard what he put in the note, other than thank you. And we're done. This little 3 is ready to go back to its home and go work for many more years to come. Land a smack down in Texas, I think. So, disconnect it. All in all, it's a good little box. I think a little box. So, it's been fun walking you guys through this process. I hope you all enjoyed the video. It was fun to go and learn a little bit more, teach a little bit more, and share a little bit more. Let's roll on out of here and let's wrap this thing up. I'm going to give a big shout out to MechMan, another one to Siglant, another one to Excess Power, and a big thanks to all of you guys, because honestly, without all of you all, I don't get to be here and do what I do. So, we're going to continue on. Next up is a 6.6 or a Sweet 16. Yay, Sweet 16. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me on Facebook. BBI Amps is the group. There's like 5,000 some of us in there playing around, having fun every single day. And on that note, I'm out. On to the next project. I appreciate you all. We'll see ya. Click, click.